Pieces of hydraulics maintenance. The safety procedures which are to be handled in hydraulic system are kept in sequence manner and seen in briefly. There are several hazardous features involved in the hydraulic system, like skin irritation, fires, explosions, environmental damage, and a slippery workplace. But hydraulic fluids are required for many machines to function. Therefore, it is necessary to follow certain precautions while using these fluids. With proper knowledge of these hazards, working with hydraulic fluids can be safe. In order to avoid skin irritations, it is necessary to wash contaminated skin immediately. It is also necessary to keep your clothing clean. Wearing masks and gloves while using hydraulic fluids is also helpful. To avoid environmental dangers, there is biodegradable hydraulic fluid option, though it is more expensive. To avoid fires, materials and fluids soaked in hydraulic fluid should be stored in sealed metal containers and disposed of at proper places. To check for leaks, use cardboard. Never use hands or fingers to search for hydraulic leaks. Maintain a clean work area free of slipping hazards. Use chemical-resistant gloves, splash goggles, and a chemical-resistant apron to avoid prolonged or repeated skin or eye contact. Never begin work on a hydraulic system until fully trained. Let us have a look at the health problems while using hydraulic systems. People can become exposed to the chemicals in hydraulic fluids. The exposure to chemicals may be due to inhalation, ingestion, or touch. There are instances of people suffering from skin irritation or weakness in hands while handling hydraulic fluids. There are also cases of intestinal bleeding, pneumonia, or death through hydraulic fluid ingestion. Though no serious hazards are reported with hydraulic fluid inhalation. Similar to ingestion, fluids can be accidentally injected into the skin as well. This takes place when the high-pressure hydraulic system hose is disconnected and toxic fluids are leaked and injected into the skin. If there is a small leak in the hydraulic pipe and someone runs their hand along it at 2000 psi, they can easily incur an injection of hydraulic fluid and may not even be aware that it happened. When working with hydraulic fluid, there is every chance that the hydraulic fluid gets heated to high temperatures. And it is evident that most petroleum-based hydraulic fluids will burn and thereby create explosions and burns. Another hazard of hydraulic fluid is that when the hydraulic hose or pipe leaks, the chemicals of the fluids can either stay on top of the soil or sink into the ground. If the chemicals get mixed in a water body, they will sink to the bottom. In fact, in such cases, the chemicals can stay there for more than a year. Aquatic life can absorb the toxic hydraulic fluid, leading to illness or death to the animal or anything higher on the food chain. Although the slimy texture of hydraulic fluids may not seem like a danger or a problem, a spill can cause a person to slip and fall. Also, when there is fluid on the hands of a person, it can cause him to slip while climbing on a machine. It can also cause the operator to lose steering control. Due to high pressure within a hydraulic system, the impact force of a disconnected and flailing hydraulic hose can cause abrasions, temporary unconsciousness, bruise, fractures, and lacerations. Proper maintenance and good pre-shift equipment inspections can minimize these hazards. Let us have a look at the common maintenance procedures for hydraulic system. Key concepts are troubleshooting, done in a logical manner, can solve most hydraulic system problems. Safety should be the first consideration when troubleshooting. Inspect the equipment and question the operator to help solve problems in hydraulic systems. Hydraulic systems operate under very high pressures. Shut the system down and relieve system pressure before opening any part of the system that is under pressure. Do not allow spray from any high pressure leak to contact any part of the body, as serious injection injuries may result. Pumps, valves, and motor may become hot. Be cautious of incidental contact between bare skin and hot surfaces. Let us now have a look at the basic maintenance of hydraulic system. Weekly once, check the system's performance and general condition. Check that the oil level in the reservoir is correct on the side glass. Hydraulic cylinder should be fully retracted when doing this. Check the oil color as compared to the sample of new oil. Check reservoir cover. Solenoids and pipe connections for leaks and tighten as required. Check the indicator on filters and replace elements if required. When replacing elements, inspect for telltale signs of impending unit failure, example, metal particles. Inspect relief valve locks, checking for unauthorized tampering. Check accumulator pre-charge where fitted. Annually and or every 3000 operation hours, check all mounting bolts for tightness. Remove coupling rods from pump or motor and check flexible couplings for wear. Replace the rubber sleeve if necessary. Check all the valve, pump, and actuator for oil leak. Remove and replace the seals if necessary. Check filler breather, suction filter, and system filters element for cleanliness and replace if necessary. Check the cooler and clean the element. If necessary, replace the seals. Have a sample of oil in the reservoir checked by a specialized laboratory for size and type of particle contamination. Drain the reservoir if recommended. Clean the tank interior and refill with fresh oil of correct type if necessary. Hydraulic system is recommended to be serviced at every 3000 operational hours or at least once a year. Continuous operation exceeding the mentioned period may cause increased contamination that may ruin components such as hydraulic pump, valves, actuator, etc. More than 90% of all hydraulic systems failure are caused by contaminated hydraulic fluid. In order to reduce the contamination level, regular or scheduled maintenance are essential. We have reached the end of this session on demonstrate knowledge of safety procedures in hydraulic systems. By now, you should be able to follow all the safety knowledge related to hydraulic systems, ensure safety for personnel and machine, list the safety precaution while working with hydraulic fluids, describe related hazards of hydraulic fluid, plan and select proper practices of hydraulic maintenance.
Hi students, today we are going to learn about identifying various hydraulic components. Let's start.
Objectives: identify and locate the element in a hydraulic circuit. Draw symbols as per ISO 1219. Let's learn what is a hydraulic system first. Any working or control system that uses liquid as the transmitting fluid is known as hydraulic system. The word hydraulic is derived from Greek words hydra, meaning water, and aulic, meaning pipe. Some common examples of hydraulic system include automobile braking, power steering, elevators, etc. The liquid used in hydraulic is generally viscous petroleum oils. The advantages of using hydraulic systems are: liquids are incompressible and capable of moving much higher loads and providing much higher force. No need to bleed off to release pressure on the load. Highly responsive compared to pneumatics. Supply more power than pneumatics. Provides lubrication and cooling automatically. Observe this image of hydraulic system carefully. Let's try to identify one component at a time. This is a tank. This is a non-return valve. This is a motor. This is a pump. This is a pressure relief valve. This is a filter. This is a directional control valve. This is a double acting cylinder. This is a pressure switch. This is a return line filter. Let's quickly recap what we have learned so far. Tank, non-return valve, motor, pump, pressure relief valve, filter regulator, lubricator, directional control valve, double acting cylinder, pressure switch, return line filter.
I hope that you have understood everything taught in this video. I will see you in another interesting and exciting videos. Thank you and goodbye until then. Hi, today we are going to learn about inspecting fluid levels, servicing reservoirs, and cleaning or replacing filters of a power pack. We are first going through the job sequence and then the skill sequence. Let's look first at the job sequence.
The objectives of this video are to identify the various hydraulic elements used in power pack, to remove, clean and assemble of suction strainer, to prepare the power pack for operation, to start and set the pressure in the power pack. Job sequence. Find the power pack of the hydraulic system after ensuring that the system is in off state. Unscrew the fastening bolts on the top to remove the top cover. Place the top cover upside down carefully so as to not damage any of the pipes. Identify the various elements, their names and functions. Also observe the order of connection. Keep the reservoir closed with a plastic cover to avoid contamination. Remove the strainer to clean and assemble it. Prepare the power pack for operation. Set the pressure of relief valve. Skill sequence. Let's next remove, clean and assemble the strainer. To remove the strainer, unscrew it. Next, we are going to clean it. To do so, soak it in thinner and blow compressed air on the mesh area. The strainer can be screwed back into the location. It should be replaced in case it is found to be damaged. Check the gasket of the top cover of the reservoir for proper seating.
Fasten the screws after placing the cover on the top of the power pack. The next thing we need to do is starting and setting the pressure into the power pack. A power pack will perform well if it is running under ideal conditions. Let's now check its condition. First, check the mounting of all units. Next, check the coupling between motor and pump for freeness. Check the level of oil in the reservoir, and if it is not up to the mark, then fill oil. Clear all the unnecessary things around and below the reservoir. Tightening all connecting hoses. Check whether the breather is placed properly. Check whether the oil drain hole is plugged and there is no oil leakage. Starting and setting the pressure in a power pack. Check whether any loose connection exists between the pipes. Turn on the electric motor of the power pack. Turn off the motor and call an electrician. If the direction of the rotation of the motor is in the opposite direction, get the required pressure on the pressure relief valve. To increase the pressure, turn the pressure relief valve clockwise. Removal of strainer. For open type of reservoir, follow the following steps. Turn off the hydraulic system after ensuring that your hands are clean. Remove the top cover plate. Remove the strainer. Clean it using thinner and blow compressed air on it. Check the strainer for any damages. If any, replace it. Screw the strainer back into its position. For a closed type of reservoir, follow the following steps. Turn off the hydraulic system. Drain the oil from the power pack. Remove the inspection cover after unscrewing mounting bolt. Unscrew the suction strainer. Clean the strainer using thinner and blow compressed air on it. Clean the reservoir thoroughly. Check the suction strainer for damages and screw it back in place. Replace inspection cover gasket. Tighten mounting screws. Fill the reservoir with oil. After filtering the oil using a mesh, confirm that there is no leakage of oil. Check the oil level. Now, the system is ready for use. Externally mounted suction strainer. Turn off the hydraulic system. Unscrew both the cap nuts attached to the strainer unit. Hold the strainer unit in the bench-wise and unscrew the mounting bolt. Remove the suction strainer. Clean or replace suction strainer. The casing should be cleaned thoroughly. Fix the suction strainer and screw the mounting bolt. Mount the strainer unit back at its position. Check whether the connections are properly made. Let's quickly recap what we have learned so far. Disassemble the power pack carefully. Remove, clean and assemble the strainer. Prepare the power pack for operation. Set the pressure of the relief valve.
I hope that you have understood everything taught in this video. I will see you in another interesting and exciting
video.
Thank you and goodbye until then.
Hello everyone. In today's video, we will go through how to inspect hydraulic hose for twist, kinks and minimum bend radius as well as tube fittings. Objectives. At the end of this video, you can be able to check the hydraulic hose, check the hydraulic pipe, check the hydraulic pipe fittings. Let us discuss on hydraulic hose. A hydraulic hose is a specialty hose that can be found in a variety of commercial and industrial contexts. Hydraulic hoses are normally made of flexible rubber or wire with a sequence of layers to provide strength and longevity. Hydraulic system in which the elements relate to flexible tubes normally called as hoses. Flexible hoses are made of synthetic rubber tube reinforced with one or two braids of high tensile steel wire or with synthetic yarn suitably covered with weather-resistant rubber. Flexible hoses are very good in taking up pulsating pressure which is dampened by the hose itself. In case of rigid pipe, this would have resulted in vibration ultimately causing breakage or loosening of connector. Advantages of using hoses. Insulates against shock noise and vibration, connects stationary parts, makes connection easier in congested place, makes good temporary connections, provides connections and disconnections which are to be frequently changed. Types of flexible hoses. Flexible hoses again are available to cater various pressures and temperature ranges. Hoses are usually classified according to the type of construction, wire braided, single or double braid, synthetic yarn braid, cotton, fiber, asbestos, etc. Normally, the flexibility of synthetic yarn braided hoses are more flexible, but the operating pressure is a limitation, whereas wire braided hoses, because of steel wire used, is good in withstanding high pressures up to 300 psi, but is not as flexible as synthetic yarn braided hose. Hoses are used in hydraulic circuits and are subjected to pressure from the oil flowing through it. So hoses are classified according to its pressure withstanding capacity. Also, this is given by the specification standard SAEJ 517 as SAE100R1, SAE100R2. The number R1 and R2 indicates the pressure and temperature. This must be noted while selecting the hoses, keeping in mind the maximum pressure produced in the circuit under construction. Type of pipe and fitting. Since hoses are used in various applications and has to mounted to suit a variety of connectors, it is also available with various end fitting. There are many types of end fitting available as required by customer. Threaded male nipple, female swivel nut female nipple. Flexible hoses are specified according to the following information: internal diameter, length between the two end connectors, pressure and temperature withstanding capacity, type of end fitting. Let us discuss the connectors. Connectors are the elements which connects the tube ends to the body of various hydraulic elements. Connectors also serve various other purposes like change in size of tube, change in direction of flow, restriction of flow, etc. Connectors can be grouped according to various parameters, according to the type of sealing design, according to the shape, size, and purpose used for. The selection of the right type of connector depends upon various factors like working pressure of system, frequency of assembly and disassembly, vibration or shock level in circuit, working area. According to the type of sealing design, flat fittings. In this, the pipe is flat and fitted to the suitable connector. O-ring compression fitting. In this type of O-ring, seals the pipe outside diameter. The split ring clamps the pipe in position. Sleeve compression fitting. In this, the pipe is formed, the neck seals the path for oil along with the sleeve. Ferrule compression fitting. In this, the ferrule is of a special design. Ferrule bites into the tube to form a permanent seal. Straight connector. To connect tube perpendicular to the body. Elbow connector. To connect the tube end parallel to the body of the hydraulic elements. Banjo connector. Banjo connector is similar to an elbow but has the flexibility to turn 360-degree with the port axis. This helps in easy positioning of the pipe with hydraulic elements. Flange connection. Big sized valves do not have threaded ports. They only have a hole as a port. In this case, a flange is mounted onto the body and the connector is mounted on the flange. This is also called as flush mounting. Plug. A plug is used to block any port of the hydraulic element to connect a tube end to another tube end. T-connector. Used to connect three pipe ends at a junction. Four-way connector. Connect four pipe ends at a junction. Reducer. Connect two pipe ends of different size. Let us discuss the do's and don'ts of tube and hose fitting. The life of the tube and hose fitting depends very much on how the fitting has been designed and installed. In the case of rigid connections, the following must be observed. Tubes should be bent such that the bend has no flats or wrinkle at the bend corners. Tubes should be installed and removed without springing, bending, or damaging the tubing. Support for tubes along the length if more than 1 meter long. Use minimum number of connectors. Use minimum number of bends in tubing. Design pipelines in a neat and straight way to make fixing and maintenance easy. Use tubes and connectors according to the working pressure of the circuitry. Make sure tubes are kept clean and clear from chips, dust, etc. that enables to detect apparent oil leakages. Points to note while using flexible hose connections. Flexible hoses are costly. Use of them has to be justified. Remember that the hose will change in length from +2% to +4% when pressurized. Provide slack or bend in the hose to compensate for any change in length which might occur. If high operating pressures are applied to a twisted hose, the hose may fail or the attaching nut become loose. Keep the bend radius of the hose as large as possible to avoid collapsing of line and restriction of flow. When hose lines pass close to a hot exhaust manifold, protect the hose with a fireproof boot or metal baffle. Use elbows and adapters to ensure easier, cleaner installation for quick inspection and maintenance. When a hose assembly is to be subjected to considerable flexing or vibration, remember that the metal hose fittings are not part of the flexible portion. Hose must be bent in the same plane as the motion of the part to which the hose is connected. Use metal wire mesh to cover the tube in areas where the hoses may meet hot chips, etc. Now let us discuss how to check the hydraulic hose. Visually check the hose for any crack. Keep the finger over the hose and slowly move along the hose and check for the kinks and twists. Check the bend radius according to the diameter of the hose. Checking the pipe fittings. Visually check the fitting for any damage. Check the pitch of the thread using screw pitch gauge. Check the fittings on inner edge and outer edge are made chamfer. Recap.
In this video, we have discussed
hydraulic hose types, connectors, and how to check hydraulic hose, hydraulic pipe and fittings. After seeing this video, I hope you will be able to inspect hydraulic hose, pipe and pipe fittings for twist, kinks, minimum bend radius and so on. Thank you for taking the time to watch. Have a wonderful day. Hello everyone. Today's video will teach you how to identify the internal parts of hydraulic cylinders or pumps.
Objectives. At the end of this video, you can be able to dismantle the gear pump, replace the worn-out component and reassemble the gear pump, test the pump for proper functioning. Let us discuss hydraulic pumps. A hydraulic pump is a device that converts mechanical force and motion into hydraulic energy. Many different sources provide mechanical power to the pump. They are electric motors, air motors, engines, and manual operation. Classification of pumps. Pumps are classified as either non-positive or positive displacement. This describes the fundamental division of pumps. Non-positive displacement pumps. The non-positive displacement type pump gives continuous discharge. The non-positive displacement pump does not provide a good seal against slippage, causing pump output to vary as the system pressure changes. The volume of fluid delivered during each cycle will depend on resistance to flow in the system. Centrifugal pumps are the non-positive displacement pumps. Positive displacement pumps. A positive displacement pump provides positive internal seal against slippage. This type of pump can deliver a definite volume of fluid for each cycle of pump operation. Closing the outlet of a positive displacement pump causes an instantaneous increase of pressure. This increase in pressure can stall the equipment or break up of components. Gear pump is an example of positive displacement pump. External gear pump. External gear pump is the most common type rotary pump. In this pump, the drive gear is turned by a drive shaft which engages the power source. The inlet port is connected to the supply line and the outlet is connected to the pressure line. As gears rotate, the volume of area on the inlet increases, thereby decreasing the pressure and making it possible for the atmospheric pressure exerted on the surface of the liquid in the reservoir to push the liquid into the inlet port. This causes liquid to be trapped in the gear space as the gears rotate and to be carried from the inlet port to the discharge port. This action produces flow of liquid into the system. A tighter seal against slippage can be accomplished by a metallic contact between the teeth ensures the seal against slippage. Important parameters of external pump. Displacement's volume 0.2 to 200 cm3 per revolution. Suitable for pressure up to 300 bar. Fixed displacement only. Generally noisy. Compact and low weight. Low cost. Let us gather the necessary tools and components for this experiment. Bench vise, Allen head socket wrench, internal snap ring plier, gear pump, O-ring, oil seal. Dismantle the gear pump. Clamp the unit in a vise from the flange side. Make sure the vise jaws are clean and have smooth surfaces. Use an Allen head socket wrench to loosen the bolts on the cover assembly. Unscrew the bolts completely and remove them. Inspect the threads for damage. Remove the cover assembly carefully. Some of the pumps may have a shaft seal. In such a case, remove the cover assembly with care to prevent any damage to the seal. Place the cover assembly on the workbench. Inspect the wear plate for wear and tear. Do not use sharp tools to remove the seal. Carefully remove the gear plate and remove the dowel pins. During disassembling the unit, mark the relative positions of the gear mesh and the body that helps during reassembly. Remove the idler shaft and drive shaft from its bearing bore. Inspect the journals and the flat faces top and bottom of the gears. Ensure these surfaces are free from burrs or scratches. If scratches are found, clean them with very fine emery cloth. Rewash the gears with light oil. Remove the wear plate from the assembly. Remove the shaft seal and snap ring from the body assembly. Use internal snap ring pliers to remove snap ring. Keep all the components of pump in proper manner and in clean place. Recap.
In this video, we have discussed the hydraulic pumps, their classification, and how to dismantle the external gear pump. I hope that after watching this video, you will be able to dismantle the external gear pump. Thank you for watching and have a wonderful day. Hi everyone. In today's video, we will discuss how to design, construct, and test a circuit to actuate a single acting cylinder and a double acting cylinder.
Objectives. At the end of this video, you will be able to design a circuit to actuate a single acting cylinder, design a circuit to actuate a double acting cylinder, design a circuit to actuate the hydromotor, select the various elements as per the circuit, construct the above circuits, test the above circuits for their function, duly arresting and leakage. See number 2. Let us discuss on single acting hydraulic cylinder and double acting cylinder. Single acting cylinder. A single port is included on a single acting hydraulic cylinder. The hydraulic fluid enters here and pushes the plunger out in one direction. Because a single functioning hydraulic cylinder is easier to maintain, it requires less work. When there is only one line, the pressure on that one line alone determines how the cylinder will function. They frequently use a spring or a similar device to extend or retract the piston rod. However, they may also rely on the force of the end to do so. When designing equipment that must be durable and dependable, simplicity is always a smart idea. Double acting cylinder. The ports of a double acting cylinder are two, one for the cylinder to be retracted and the other for the hydraulic fluid to enter and extend the plunger. Pumping hydraulic fluid to both sides of the plunger is possible with double acting hydraulic cylinders. The piston rod can travel forward and backward thanks to connection apertures located close to both ends. The additional port guarantees that the plunger always returns to its starting location and gives the user more control over the plunger during retraction. Double acting cylinders are a superior option for projects requiring repeatable accuracy due to their quicker and more predictable retractions. Hydromotor. This is a rotary actuator used in hydraulics, also called as hydraulic motors. This is very useful when a rotary motion is required. The rotary action is achieved by these hydromotors. Similar to linear actuators, this also can be controlled in terms of displacement, direction of rotation, pressure or torque requirement. Cylinders provide linear motion whereas hydromotors provide rotary motion. Various types of hydromotors. Hydromotors are classified according to their internal design. Hydromotors are of three types, namely gear type, vane type, piston type. All these types have the common principle of working. These almost resemble a hydraulic pump in construction. Operation of hydraulic motor is opposite to that of hydraulic pump. Gear type motors. Gear motors are designed either as gear-on gear motor, external gear, or gear-in gear motor, internal gear. In gear-on gear motor, oil enters the inlet port with pressure. This oil forces the gear to rotate and the oil flow out of the outlet. The speed of the motor depends on the amount of flow per minute and the motor torque depends on the pressure of oil. These motors have the lowest volumetric efficiency of about 70 to 80%. The pressure of oil creates the torque in the same way as that of on a lever. Vane type motors. This differs in the design when compared to gear motor. The simple line shows the vane being moved along with the shaft by the oil flow. The prominent feature of the vane motor is the sliding vane. Each shaft will have more than one vane, which ensures continuous rotation of the shaft. The vanes in the slots extend out by the action of centrifugal force and oil pressure. This has a high-speed operating character. Piston type motor. Piston motor is totally different from the other two types in its construction. Piston motor are of two types, namely axial piston motors, radial piston motors. These motors are the most volumetrically efficient motors, rating up to 95% efficiency. In a piston and barrel assembly, when oil with pressure is allowed, it pushes the piston out. Speed control of hydromotor. This is controlling the RPM of the hydromotor. This is usually done by controlling the quantity incoming fluid. This is also called as the displacement of the hydromotor. The control of flow of oil can be done by various methods, which will be discussed in coming chapters. Speed of a hydromotor depends on the quantity of oil passing through the motor. Torque control of hydromotor. Torque obtained in a hydromotor is the function of the fluid pressure. Thus, by controlling the fluid pressure of the hydromotor, the torque is also controlled. Direction control of hydromotor. This is done by using a direction control valve in the circuit. This very much resembles the method of controlling the direction of movement of a double-acting cylinder. Direction of rotation of hydromotor depends on flow path of the oil. Specification of a hydromotor. A hydromotor is usually designed and specified by the following parameters: maximum torque required, maximum RPM required outlet, maximum operating pressure, efficiency. How to select a hydraulic cylinder for an application? Number 1. Mass cylinder. Identifying the mass you want to shift is the first and most important stage. After determining your mass, you must think about how it will affect the force needed to move it. In contrast, pushing a 1-ton burden across the ground will only require enough force to overcome friction and acceleration. For instance, pushing a 1-ton load straight up will take slightly over 1 ton of force. No matter what, the cylinder force should always be sufficient to account for inaccuracy. Number 2. Stroke. The distance travelled by the piston through the cylinder. Number 3. Stroke length. Stroke lengths are the dimensions of the piston. The length ranges from fractions of an inch to several feet. Operating pressure. The operating pressure range describes the entire needed operating pressure range. Bore size. The interior diameter of a barrel is measured by its bore size. Body material. Aluminium, steel, stainless steel, and plastic are common body material choices. Rod length. The rod diameter dictates how much load the piston can withstand before it buckles. The minimum rod diameter under various load circumstances is shown in the table below. The exposed length of piston, as shown at the top of the table, is often greater than the cylinder's stroke length. Speed. Speed is controlled by valves that regulate the flow of hydraulic oil into and out of the cylinder. Typically, cylinders are permitted to operate at their maximum natural speed. The maximum speed is determined by the cylinder size, port size, air pressure, hose bore and length, and the load that the cylinder is working against. Force. Force is connected to piston diameter, however, they are not directly proportional. In general, the larger the piston area, the more force is produced. Force ratings might differ somewhat in opposite directions. When propelled hydraulically by the same supply of compressed fluid, the in-stroke pull force is less than the outstroke thrust force due to the effective cross-sectional area being reduced by the area of the piston rod. Design, construct and test a circuit to activate a single acting cylinder. Step 1. Draw a circuit diagram to activate a single acting cylinder in the given format and get the approval of instructor. Step 2. Include elements to activate cylinder and also to monitor pressure at various points in the circuit. Step 3. Select the hydraulic elements as per the approved circuit diagram drawn. Step 4. Mount and connect the elements on the trainer kit. Step 5. Get the approval of your instructor before switching on hydraulic pump. Step 6. Switch on the hydraulic pump. Step 7. Inspect the circuit for any leakages. Step 8. Eliminate any leakages by retightening connectors pipes. Step 9. Put off hydraulic pump while tightening connector and pipes. Note the position of valve and position of cylinder in the tabulation. Step 10. Activate the direct control valve and note the new position of valve and cylinder. Step 11. Put off hydraulic pump. Step 12. Disconnect the valves and other elements and place it in respective places.
I hope that after viewing this video, you will be able to design and build hydraulic valve circuits using various valves. Thank you for watching. Have a good day.